Do you know, in every day, millions of apps runs on GraphQL, from buy now pay later payments to food delivery and retail checkouts. So one endpoint provides incredible flexibility for app developers to get their exactly need. If the endpoint is not properly controlled over the queries, the same flexibility is provided for the attackers as well. Good evening, everyone. I'm Hiranya Abeyrathne, Technical Lead at WSO2. I primarily work on API management, focusing on emerging API technologies, strengthening their security, and advancing SaaS API management capabilities. Over the years, I have seen how GraphQL has revolutionized APIs. It's fast, flexible, and powerful. But that same flexibility also opens door to new kind of attacks. So, few months ago, I started a project at WSO2 to explore how AI can help to detect GraphQL attacks that traditional rules often miss. And today, based on that research, I'll show you how we can defend GraphQL at every layer intelligently. Let's start with a simple use case. Imagine you are doing an online shopping. You add your items into your cart and finally you are going to check out. At there you can see buy now and buy now pay later option. Let's say you click the buy now pay later option. Underneath it will trigger a GraphQL query where it fetch your orders, apply discounts and check your credit limit and arrange the shipment all at once. Now flip it. If the backend authorization is misconfigured or a token is stolen, an attacker could send a malicious query like update credit limit mutation. So what will happen? Just with the schema knowledge, they will send that kind of malicious query, will effectively inflate your credit limit and access customer data and trigger ghost checkouts. What's the true cost? It will flood losses, compliance fines, and loss of trust. One query, millions at stake. So these are not hypothetical, these are happening in real world too. These are some of the news I taken from news sites. So Kiosk Mesh, it exposed a full remote code execution vulnerability via GraphQL. Attackers could execute commands in the cluster. And Zimbra collaboration suite leaked sensitive user data due to missing authorization and CSRF issue. And GitLab, it disclosed high severity DOS flaws that could crash entire instances. And Burger King digital systems were breached via an introspection endpoint and create token mutation by enabling attackers to escalate the admin privileges. So altogether, they all show that GraphQL vulnerabilities span different attack types. So what do you think? Why it is so hard to detect GraphQL attacks? So here we have to understand there are three distinct risk layers: structural abuse, payload and semantic attacks, and behavioral and business logic abuse. So, structural abuse, so attackers can send deeply nested or alias flooded queries and batch requests to overwhelm the backend. And secondly, payload and semantic attacks, attackers send hidden obfuscated payloads within hiding within the variables and fragments to do the SQL injection, XSS, OS command injection, SSRF, CSRF kind of attacks. Next, behavioral is business logic abuse, which is most insidious and behavioral issue. So individual queries looks normal, but when chained together fetch promos and prop checkouts, then escalate the credit. The intent becomes clear. The point is defending GraphQL means defending structure, payload, and behavior, all attack vectors, not just one of them. Let's map the incidents that we have discussed earlier with the attack vector. So GitLab represents structural abuse where complex queries overload the systems. And Zimbra collaboration suite and Kiosk Mesh fall under semantic abuse, where the payload itself carries malicious intent from CSRF to OS command injection. And Burger King digital systems illustrate behavioral abuse, where the legitimate queries were chained together to over time for takeover and then financial fraud. So when you step back, these incidents clearly show that GraphQL attacks span over three distinct layers. So can we defend these issues with traditional mechanisms? What do you think? Answer is no, because traditional tools were not built for the GraphQL. If you see the static core analysis tool, which you can massively see currently, so those are focusing on the query shape, not the intent. And the threshold value which are set at there can be too strict or too loose. If it too strict, it could directly impact the legitimate users. If it too loose, attackers can easily get rid of the attacks. How about rate limits and depth checks? Those are focused on the speed but not the intent. They are blind to low and slow semantic abuse. How about firewalls? They were built for the rest. They treat the GraphQL as plain JSON. They blind to nested variable driven structure. So the that gap is that attacker exploit. Traditional defenses fail because they look only at the query shape, not the meaning. So if you go to the GraphQL security report into 2024, which has been published at Cybersecurity News, it says that Gartner predicts 60% of enterprises will adapt to GraphQL by 2027. And same report said 69% of GraphQL APIs vulnerable to DOS attacks now. So what we can get from this? GraphQL adoption is accelerating, and attacker surface also getting expanding. So that's why we need a smart adaptive defense mechanism to get rid of GraphQL attacks properly. So to close the gap that existing solution miss, we need defense mechanism that go beyond static rules. So as you all know, AI brings three strengths: semantic understanding to understand intent, behavioral awareness to see what's normal, what malicious, and adaptive learning, which means to identify the evolving new attack patterns. So, uh, altogether, we can properly defend the GraphQL attacks intelligently. So, how about the rules? Static rules are still matters. They help to identify surface level risk like deep nesting, LISO use, and so on. But rules are shallow. They don't ask why factor. But AI dives deeper, see the payload, and correlate with the context and identify the user patterns. So, future of GraphQL security is not either rules or AI. It's both. Both together, it can do a uh, intelligent and defensive, proper defense against the GraphQL attacks. So, uh, so this is time to introduce our proposed unified defense model for GraphQL APIs to protect the GraphQL APIs from structural, semantic, and behavioral attacks. So it has three AI defense layers. To defend against the structural abuse, we can use LLM driven policies instead of using hard coded threshold for the limits. To defend against the payload abuse attacks, we can use embedding based natural language processing model to inspect the payloads at runtime. And to defend against the behavioral and business logic abuse, we can rely on an adaptive per API model with a sequence analysis to track the uh, user and session behavior to identify the anomalies. So this is the overall architecture of the model. So once the query reaches to GraphQL gateway, it can be passed into GraphQL defense engine, which has tree detectors and decision engine. And LLM policy generator, which is exposed during the design time, and it will connect with the structural abuse detector to push the smart policies. And decision engine, it pass the feedback or log to defense intelligence loop to uh, make the model adaptive to live traffic. So it will connect with the LLM policy generator and adaptive learning engine to refine the policies and model improve the model accuracy. So let's start with the defense layer 1. Here it involves LLM policy generator and structural abuse threat detector. So here, API developer can provide GraphQL API SDL with short developer prompt mentioning about the how the backend behave to LLM to generate context-aware policies which learns each API schema and constraint. Then it can enforce API-specific LLM policies and runtime to detect what kind of structural issues are there. So here, developer prompt is very important because SDL itself hard to say how the backends should behave, intend to be behave. But API developer can mention what kind of use cases are there, what are the expected query patterns, what are the heavy fields, what are the sensitive fields, what kind of access control should be there, if introspection queries are exposed. So those kind of guideline can be provided under developer prompt to have a proper precise threshold values. So this is how we can have first line of defense adaptive and schema aware rather than go for a static or generic. So now payload and semantic threat detector. So it is for that one we have to build an API specific dedicated SBIRD embody model which generate trend on a standardized dataset. So for that, we can use GraphQL SDL and vulnerability templates like SQL Engine SSS or OS command injection, source from public dataset like Kaggle. So all together we can generate benign obfuscated label dataset, and we can train it on a SBIRT embody model to learn the payload semantics and intent. And then we can enforce the model at runtime through the payload and semantic threat detector to inspect what kind of malicious payloads are there. And then we can correlate payload signals with the metadata like the origin, referrer, and headers, rates like frequency and resolver type to properly get the idea on the uh, request. So that's how we can defend against the payload and semantic attacks. And next, layer 3. So this layer focuses on understanding how users interact with each API over time. So for that, we need to build a baseline of normal behavior from live traffic because it start with a cold start learning. So next, we track the query sequences and user sessions using a powerful combination of graph-based and streaming analytics. Then we can correlate the crucial context like user actions, timing, and metadata to get the complete picture of the request. Then we can feed all of this information into machine learning or AI model like anomaly detection model, like gated recurrent unit, which is faster than long short term memory models. So it can flag the anomalies like data harvesting or from misuse by spotting the deviations from the normal baseline. So that's how defense layer 3 works. Then decision engine. So the decision engine evaluates a signal from all three detectors uh, and produces combined risk score, and then it applies adaptive rules and conceptual logic to determine the right actions like whether it allows, restrict, throttle, block or reject, or re-authenticated, or just only sanitize or flag. So, so decision engine provides a feedback into defense intelligence loop to make it evolve with the observability. So here, mm, in defense intelligence loop capture every query request, and then it evolve the pattern through the across the time, users and endpoints. Then it make it allow to continuously learning from the real traffic to confirm the incidents and pass the data into LLM policy generator and adaptive learning model to uh, make it more precise, accurate model uh, uh, with the time. So here, the most important thing is uh, when we retrain the adaptive learning model, there should be have human intervention too in order to prevent from the false positive. Also, when retraining the model, we need to avoid the catastrophic forgetting to preserve the prior knowledge to keep the higher accuracy of the models. So that's how the model works overall. And now challenges. So here we are dealing with the AI. So there are some sort of challenges too. So these are some of the challenges we can listed here. So here graphical schema changes fast can change fast, which makes detectors brittle. So our detectors and policy generator should be evolved with the schema change. And data generation for semantic model needs to have high quality label data. And many attackers are stealthy, so slow and low extra filtration or multi-step privilege escalation can be there. So sequence model need to have sufficient history to detect them. And attackers are clever and they can rotate their IPs, spoof header or jump sessions, and payload also can be complex and and most importantly scaling AI models. So real-time inference with a large model can be costly or slow, but there are so many uh, optimization mechanism to apply for those model. So the challenge is balancing speed, scale, and accuracy in real time. But acknowledging these challenges is what makes adaptive security resilient. So yeah, so let's zoom out what we discussed today. GraphQL gives developer power, but attackers has a broader surface to get rid of from the entire one through the endpoint. So static thresholds are brittle because if they are too loose, attacker can get rid of them easily. And attackers are within the spec, so they can they the existing mechanism can't understand the intent. And then our unified defense model, which has three AI defense layers, to where has LLM generated structural policies for structural abuse detection, and machine learning and natural language processing embedded model for semantic detection, and behavior analytics for multi-step abuse detection. So then decision engine, so to enforce the right action with the feedback uh, and then continuous learning loop, which get the feedback from the decision engine to continuous learning loop to continue tuning with observability and real traffic feedback. So the result is unified adaptive defense that evolves with your APIs, moving from reactive protection to proactive intelligence defense. Uh, Thank you.